I'm Rachel.
And I'm Ryan.
And today we are going to talk about the law of sines and cosines.
We use the law of sines and cosines when the triangles we are given are not right triangles. If we were given a right triangle, we would instead use the Pythagorean theorem. To start off, here's the formula for the law of sines. When solving a non-right triangle, the law of sines is the first method you should attempt to solve the triangle. In trigonometry, lowercase letters represent sides while the uppercase letters represent angles.
Angles and sides come in pairs. For example, the side opposite of angle A is side length A.
The formula for the law of sines is the sine of angle A over the length of side A, which is also equal to the sine of angle B over the length of side B, which is also equal to the sine of angle C over the length of side C. This can also be flipped for the lengths of each side to be in the numerator.
The formulas for the law of cosines are as following. When solving for angle A, use the first formula. When solving for angle B, use the second. And when solving for angle C, use the third.
Notice that in the formula, the side length of A squared is equal to the cosine of angle A. The letter on the left side of the equation must always correspond to the cosine of the angle on the right side. We can identify which law we should use based on the number of sides and angles we are given. We can use the law of sines when the triangle is either SSA, which is also known as the ambiguous case, or AAS, or ASA.
There are two cases where the law of sines cannot be used, and we must use the law of cosines. If the triangle given is SAS or SSS, in order to find the other sides and/or angles, we must first use the law of cosines.
Now let's try an example.
The triangle that is given has three sides. Therefore, we must use the law of cosines.
In order to avoid the ambiguous case, we should use the longest side first to solve for the angle. In this case, it is side A.
Now we will substitute the numerical values in for each variable.
From here, in order to find angle A, we must take the inverse cosine and multiply it on each side. Angle A is equal to 95.8, rounded. Since it's greater than 90 degrees, we have avoided the ambiguous case.
Now we must use the law of sines to find the second angle measurement. Next, plug in the numbers to solve for the angle measurement of B.
After plugging in the inverse of sine, B equals 50.8.
To find angle C, we can subtract angles A and B from 180 degrees.
Or you can find angle C by using the law of sines.
After finding angle C using the law of sines, all three angles may add up to a bit over or under 180. This is because when solving for each angle, the values were rounded to the nearest hundredth.
Angle C equals 33.4. Since we found all the angles and they add up to 180 degrees, we have finished solving the triangle.
Thanks for watching.